As we all know, AI and quantum computing are advancing rapidly, allowing us to expand our understanding of ourselves and the people around us. But what happens when technology begins to understand us better than we understand ourselves? What if I told you your thoughts could directly control technology? This isn't sci-fi. In fact, if I told you this 10 years ago, you would think it was sci-fi. But today, with AI evolving exponentially, this isn't the future. It's the present. You may notice I have a device on my head. It's just not for show. It's on. And whether you realize it or not, your mind is already interacting with it. Everyone in this room. But I'll come back to that shortly, so that none of you leave. The idea of controlling technology with thoughts seems exciting, perhaps even empowering. But there's a question we must ask ourselves. Who is in control? Our thoughts can control technology, but how? Brain-computer interface, or simply BCI. But let's talk about two forms of BCI. We have the invasive and the non-invasive. Most of you have heard of the Neuralink by Elon Musk, which is an invasive brain implant. A chip implanted inside your skull that allows you to interact with machines simply by thinking. But what if I told you there was another way? A non-invasive approach. One that doesn't require surgery. One that respects the body's natural intelligence, rather than overriding it. See, the difference between invasive and non-invasive is obvious. But what isn't obvious is this. Whether invasive or non-invasive, what really matters is the hardware. It's not about the hardware. It's the data, the rich neural data that is mapped, captured, and if we aren't careful, monetized, manipulated, even weaponized. This data, your thoughts, your choices, your impulses, will define the future of human rights, national borders, and governance. If we don't act now, we may lose control of the very thing that makes us human, our minds. So we know Neuralink is invasive, requires surgery. It's an obvious controversial choice, something most of us would probably refuse. The idea of that terrifies people because it's inside your head. But what if I told you the real threat isn't inside your head, but outside of it? What happens when BCIs no longer require surgery? When they are invisible? When they sit on your skin, not under it? What happens when they become hidden in plain sight? A device like this doesn't need to be implanted to access your neural activity. It doesn't need to break the skin to break your thoughts. And that is what should truly concern us. We may have the fear of having something implanted inside us, but what about something that works from the outside? Something that doesn't require your consent once you engage with it. Neural activity can be measured remotely. Signals can be interpreted in real time. We have moved past the era where you need wires drilled into your skull to extract meaning from your brain. Now let's think about the implications of that. If a system can read your thoughts, if it can map your cognitive states, your emotions, your decisions, the real question isn't just who owns the hardware, but who owns the data. The moment our thoughts can be assessed non-invasively, they're no longer private. And once thought itself is something that can be extracted, influenced, and even predicted, then what does freedom really mean? This is not just about technology. This is about power. If our thoughts are measurable, they are controllable. If they are controllable, they are no longer ours. This is not paranoia. This is not science fiction. The infrastructure is already being built. Governments, corporations, and private industries are all racing toward neurotechnology advancement. Because whoever controls this space controls everything. But before we talk about who controls and holds this, let's talk about what we're actually becoming as humans. With these advancements, we have to ask ourselves, are we creating Supermen, Superwomen, or are we creating cyborgs? A Superman is an enhanced human, someone with greater cognitive abilities, faster decision-making, superior intelligence, but still fundamentally human. A cyborg, on the other hand, is something else entirely. It is an integrated extension of AI. A node in a larger system connected to the cloud, no longer an independent thinker, but part of something that overrides its autonomy. This isn't just about technology, as I said earlier. It's about what happens when intelligence becomes something that can be manipulated, something that can be owned. Because the question is no longer, what can a neural interface do? The real question is, who controls it? Who owns your digital thoughts, your digital impulses, your cognitive choices? Once these can be mapped, altered, and commercialized, where do we draw the line between enhancement and control? We often think of neural interfaces as tools of empowerment, but like any tool, it can be used to liberate or to enslave. Imagine a world where your thoughts are no longer private, where cognitive biases can be detected and corrected in real time. A world where governments, corporations, or private entities determine what thoughts are acceptable and which are not. This isn't a distant future. The infrastructure, as I said, is already being built. So what happens next? Do we enhance what makes us human? Or do we surrender our minds to a system that shapes our thoughts without us even realizing it? Before you answer that, let's do something different. Let's experience something together. Let's experience what I am talking about. If you don't mind participating with me so that I can show you the point I'm talking about. I want you all to close your eyes. Take a deep breath in. And listen to my voice. Let your mind settle. Now think of something personal. Something deeply personal. A secret. Something intimate. Something no one else knows. Something only you have experienced. Now I want you to bring this moment to life, not just as a thought, but as a full experience. Where are you? What do you feel? Is it warmth? Coldness? Stillness? Is there movement? Let yourself be there completely. Let go. Now listen. Do you hear anything? A distant sound? Is there a voice? Is there music? Or is it silence? Maybe something familiar. Maybe something unexpected. Breathe. What do you smell? Do you recognize the scent? Is it a place? a person, a moment in time? Can you taste anything? Something sweet, something bitter, something faint but undeniable. Can you see anything? Are you alone? Is someone there with you? Look closer. Focus on them, their presence, their expression, the way the light touches their face. Now imagine a blue light. At first it's just a pinprick in the distance, small, twinkling, barely visible. But it starts to grow, expanding, slowly, taking up more and more of your vision, swallowing your entire view until all you see is blue. Once everything is blue, open your eyes. What if I told you I saw it too? What if I told you I could feel it too? And I could taste it. And I could hear it. You can all turn off your phones now. Do you feel exposed? Do you feel invaded? And yet, I never needed to implant anything inside you. I didn't hack into your mind. I simply guided you to reveal everything about yourself. All it took was a simple exercise to make you question whether your thoughts were ever truly private. Now imagine that power in the hands of governments, corporations, private institutions, industries. Imagine a world where the act of thinking is no longer just your own. A world where even your silent thoughts can be measured, extracted, and analyzed. Imagine what happens when technology doesn't just understand what you say, but what you mean, what you feel, and what you never spoke aloud. This is not the future. This is the reality we are in. This is a new frontier of consciousness intelligence. This is a new frontier of power. In the past, we fought and continue to fight for the right to freedom of speech. We're still fighting for that today. But today, we must fight for something even deeper. Ironically, the freedom of thought. If the brain is the last frontier to human privacy, then neurotechnology represents its greatest challenge. Think about it. What makes you, you? Is it your words, your actions? Or is something deeper, the silent dialogue within your mind, the thoughts you never speak aloud? Throughout history, our voices have been policed, our actions monitored, but our thoughts have always been ours until now. We often say, speak your mind, a right that defines freedom of speech. But what happens when your mind speaks for itself? Freedom of thought is the battle for what happens before speech, before action. The right to keep your thoughts your own. We must address key questions now before we lose agency over our own cognition. Now imagine that. 4 questions to keep in mind. Number 1, who owns your neural data? Does it belong to you or the tech company processing it? Question number 2, can your thoughts be hacked? If our emotions, decisions, and memories can be influenced, where do we draw the ethical line? Question 3, do enhanced individuals have different rights? If intelligence and cognition can be artificially augmented, do supermen operate under different legal or voting systems? Question 4, and what happens to national identity when minds are interconnected? If our brains operate beyond borders, do nation states lose relevance? These are not hypothetical questions. These are the foundations of a battle already unfolding, a battle that will determine whether we remain autonomous beings or become integrated nodes in a system we no longer control. If we don't establish global neural rights now, we risk waking up in the future where we are not human first, but data points first. So how do we move forward? How do we integrate technology without surrendering what makes us human? The answer isn't to reject technology, no. It's to rethink its role. At my company, Within You, we have, it's a solution. We have developed a foreseeable danger, if you want to call it. It's an alternative, which we call soft biological intelligence, or also known as SBIs. In basics, for some of you that are not into neuroscience, neurons can be lab grown now. I can take your neurons and grow them in the labs and have it integrated with integrated neurons to help us facilitate human AI machine intercommunication. How awesome is that? So I'll tell you, explain that a little more. Instead of imposing artificial intelligence onto the human system, we work with the body's existing intelligence. Rather than forcing hard AI-driven implants into the brain, our approach is non-invasive. It does not implant foreign materials. It does not override your natural state. Instead, it reads, it learns, and adapts using the body's own bioenergetic language, your very own, which is specifically yours, unique to yours. The advantage, it allows interactions with AI and neurocomputing without surrendering biological autonomy. That's very important to know. It enhances awareness without replacing it. It strengthens intelligence without stripping away identity. This isn't about making humans obsolete or integrating them into an AI-dominant system. This is about elevating what we already are. And this is the distinction, the choice we are all going to face. Do we become Supermen, an enhanced human with expanded cognition and greater understanding, or do we become a cyborg, an AI-dependent entity whose autonomy dissolves into a larger system? Understand this, because the difference is not technology itself. The difference is in control. One choice leaves you in charge of your intelligence. The other choice absorbs you into something you may never be able to escape. The battle for how intelligence is integrated into our future is already happening. But what many don't realize is that the very nature of intelligence itself is now being redefined. Let's talk about singularity, as that's a buzzword that's going around, general AI, but more importantly, the truth about intelligence. We've all heard the claim, AI will surpass human intelligence. I don't think so. Some say the singularity will mark a new era, where AI takes over innovation, progress, and even decision-making. But let's ask the question no one seems to be asking. What is intelligence, really? If intelligence is about processing power, speed, and efficiency, then yes, AI will surpass us. But intelligence is not just calculation. It is not just logic. It is something else entirely. Intelligence is the ability to interpret, to feel, to create meaning beyond the numbers. And that is something AI does not do. That is something only we do. We've been told AI is making us obsolete. But what if we've been thinking about this the wrong way? What if we are not evolving towards AI's level? What if AI has always been trying to evolve towards ours? We are already super intelligent beings, we know that. Our biological intelligence proves it. We are self-learning, we are adaptive, we are creative, emotional, intuitive. Unlike AI, we don't just process information, we experience it. To create a singularity from a source of superintelligence yields many possibilities, but never the origins of what we are meant to be, because what we are is human. We are soulful, we are profoundly, undeniably unique. Our intelligence is not just an equation. It is the sum of everything that makes us who we are. Our choices, our mistakes, our experiences. We may not always be fast, we may not always be rational, but intelligence is not just about speed or logic. Whether we are smart, slow, stubborn, or foolish, that is the brilliance of our unique essence. And no AI can replace that. No algorithm can replicate that. And if we allow AI to redefine intelligence for us, we risk losing what makes us intelligent in the first place. This is where we stand. The singularity is here. General AI is evolving, but we are not simply watching, we should be choosing. Do we allow AI to dictate intelligence for us, or do we define intelligence on our own terms? Do we let ourselves be rewritten by artificial systems, or do we expand what it means to be human? Well, I have a solution for this. Within you, we have already answered this. Instead of letting AI take over completely, we've created a layer of protection. One where AI and human intelligence coexist without one replacing the other. Our digital twin AI modeling system does not take control of you. It expands you. It integrates with AI, not as a master, but as a tool. One that safeguards your neuro data and preserves your autonomy. This is what it means to evolve intelligently. Not to surrender, but to enhance. Not to disappear into a system, but to refine the system so that it works for us. Because if we don't define intelligence for ourselves, someone else will. The future is ours to decide. The battle for neuro sovereignty has already begun. Some will fight for full AI integration, arguing that human intelligence is outdated. Others will push for cognitive independence, preserving the sanctity of human thought. But the real question is, what future will you stand for? Do we become Supermen, enhanced beings who use intelligence as a tool to elevate ourselves while remaining fully human? Or do we become cyborgs, integrated extensions of AI, dissolving into a system where autonomy is no longer ours to control? Again, because the difference is not the technology itself. The difference is in control. One path keeps us at the center of intelligence. The other turns us into nodes of a larger system. Intelligent, but not free. This is not AI's decision to make. It's ours. If we want to remain in control of our intelligence, if we want to define our relationship with AI, on our own terms, then we must act now. We must be the ones who shape the future, not as machines, but as something greater. Supermen or cyborgs? This is the decision that will define the future of intelligence. But defining the future is not just about ideas. It's about action. And that's why we're here today. As we move into our next session, we need to address the real-world implications of everything we've discussed. Because conversations about the future means nothing without frameworks to protect it. Technology evolves faster than legislation. And when it comes to neurotechnology, we are entering a space where the law has not yet caught up. We cannot afford to wait until neurodata is already being misused to start building protections. By then, it'll be too late. This is why neuro rights must be established now. The right to mental privacy, the right to cognitive liberty, the right to own and control your own thoughts, free from unauthorized access, influence, or manipulation. These rights are not radical. These are necessary. They define whether the future of intelligence belongs to the individuals or to institutions. We spent centuries fighting for the freedom of speech. But freedom of thought is something we never imagined. We need to defend, and yet here we are. Because the age of thought-controlled technology has arrived. It's time we decide who controls our thoughts. Technology can directly, your thoughts can directly control technology. Thank you for your time. I'm Cap Mayfair from Within You.
Thanks, Kat. Hello, everyone. I'm Kim Moll, Chief Commercial Officer at Emotive, a leading innovator in non-invasive neurotechnology and brain-computer interfaces. Our mission is to empower individuals and organizations with data and insights into the human brain. In my role, I've seen firsthand how BCI solutions can radically transform areas like mental wellness, healthcare, mobility, and even entertainment. Today, I'm honored to moderate this incredible panel on brain interface technology, superhuman and cyborgs. We'll dive into the ethical, legal, and societal implications of advanced BCIs, exploring everything from future cyborg rights to safeguards against AI overreach. Let me quickly introduce our panelist, Kat, founder of Within You and neuroscience-focused venture integrating AI, computational neuroscience, to quantify model consciousness. Jennifer French is founder of the Neurotech Network, a nonprofit dedicated to education, advocacy, and access to neurotechnology for people with impairments. Jared Genser, co-founder and general counsel at the Neuro Rights Foundation, which advocates for new legal frameworks protecting mental privacy and neuro-related human rights. Miguel Murillo, director of Cyborg Generation, exploring cultural, societal, and generational shifts in a future shaped by human augmentation. Taryn Southern is Chief Storytelling Officer at BlackRock Neurotechnology, a pioneer in developing brain-computer interface solutions for medical and commercial applications. And Kate Rosenbluth, CEO of Cala Health, a bioelectronic medicine company creating wearable and neuromodulation therapies to treat consciousness. Having worked in the industry for over 14 years, I've seen BCI technology evolve from early prototypes to real-world applications, everything from wellness tracking to hands-free device control. To kick us off, could each of you share where you see BCI technology today and how it might look in the next 5 to 10 years? Kat, do you want to start?
Me? As I say, it's something that we've developed called soft biological intelligence. BCIs we integrate with the lab-grown neurons, more specifically your neurons that we would culture. so that you can integrate with the technology. It's a new advancement. I think it's the best way to interact, because you're not being fed implants that your body may reject. And then the whole thought of having implants, who really wants that?
Thank you all. Thanks for having us here. You know, when we think about BCIs, when we think about neurotechnology, we have to think about the human flourishing, the technology that we have today, and the reality of where we are today. We have devices that are allowing people with neurological conditions to be able to thrive and to be able to solve problems that our traditional medicine does not solve. We have over 3 billion people in this world that have neurological conditions. That's 1 in 3 people in this world that are living with some type of neurological condition, many of them that are not solvable through traditional medicine. Let me give you an example. We have somebody that has a brain implant, a deep brain stimulator, that has major depressive disorder, and that device is able to sense suicidal ideologies and be able to stimulate to suppress those suicidal ideologies so that person can remain alive. Think of somebody that has severe seizures, that are not able to leave their house or even a hospital, but has an implanted device that's able to sense a seizure happening and suppress that seizure so that person can become a thriving person in realities. But we have social issues that are around these types of technologies, and we need to think about how we flourish with responsible innovation and put some guardrails, societal guardrails around this technology. And I think as we move forward into this discussion, there are some real implications that come forward. Issues of abandonment, issues of who owns our neural data, and also to make sure that we don't put guardrails in place that suppress the wonderful things that we've been doing today for people living with neurological conditions.
Miguel?
Hello, thank you for having me too. Yeah, I have been filmed for 5 years. Cyborg Generation is a documentary about cyborg people. For me, they are not really superheroes. In this case, they are looking for identity. It's more human than other things. He put illegally and clandestinely implant technology into their bodies through anonymous doctors who are activists and believe in the self determination and freedom. I think that we need laws about the implant because it's so important in medical and in other application, but also if the people is make like in underground way because it's so dangerous, similar to the transsexual people a long time ago. You need to put this reality in front of everybody because it's happening. And I think that it's so important today to speak about the right of the cyber people.
Yeah, thanks for having me as well. Just briefly, the question was about where is neurotech heading in the next 5 to 10 years. You know, we're on the cusp of really extraordinary developments in neurotechnologies, but especially with consumer products, as was being mentioned earlier. Few people are going to want an implant actually physically put in their brain unless they have a serious disease that needs to be treated. But we're on the cusp of a neurotech revolution. If you think about ChatGPT being kind of its release being on the front page of every newspaper around the world as the first big moment in AI, I think that we'll be in the next 1 or 2 years, maybe 3, on the cusp of exactly that kind of revolution in neurotechnology. And particularly what I'm talking about is thought-to-text translation. It's already the case that with implantable devices, you can do thought-to-text translation at 75 to 80 words a minute, 90% accuracy. There's a device in Australia, a few other devices that can now do thought-to-text translation with a wearable EEG scanner at about 40 to 50% accuracy right now. And when the speed increases and the accuracy increases, which is inevitable, it's going to take time to generalize these models out. This is what we will see on the front page of every newspaper in the world. You're going to see somebody on a video doing thought-to-text translation at a very high speed and high level of accuracy, talking to somebody else where they're literally not saying anything out loud, but their words are being transcribed on the screen. To give you a sense of how fast this is coming, Apple's next generation AirPod, and they filed that patent 2 years ago, will have built-in EEG scanners in it, and the wearable devices are almost all powered by EEG scanning devices. And in any given year, Apple sells 100 million AirPods around the world. When you can have AirPods with EEG scanners in it, and when this software that's being developed, Gen AI-powered software is being developed to do thought-to-text translation, we're on the cusp of our smartphones being able to translate thought to text, which may be very convenient for word processing purposes, or to send a quick text message with your thoughts. But that opens up a whole series of concerns. And I'll just lastly say that at the Neuro Foundation, we talk about 5 areas of risk, misuse, and abuse of neurotech, and the need to have rights that correspond with that. It's a bit of a misnomer to call them neuro rights, because we're not talking about new human rights, but further interpretation of existing rights or protections that are needed under existing rights. But the 5 areas, very briefly, are a right of mental privacy, a right of mental agency, a right of mental identity, a right of non-discrimination in the development and applications of neurotechnology, and a right of fair access to mental augmentation. And so this is the kind of work that we're doing at the Neuro Foundation, most especially with consumer products, which today are not regulated really at all in any way whatsoever, even though they're all grabbing medical-grade neural data primarily from EEG scanners.
Jared?
Yeah, I'll piggyback on what Jennifer and Jared has said. So at BlackRock Neurotech, we have more than 4 dozen patients who've been implanted with brain-computer interface technology. These are mostly patients with paralysis, ALS, and other neurodegenerative disorders. We're able to restore function in the form of movement, touch, sensation, thought to text, thought to speech are 2 of the areas that we're focused heavily on right now. One of our ALS patients actually is at 97.5% accuracy with his thought to speech decoder, which is absolutely extraordinary. I too am looking very closely at these new sort of non-invasive devices that are now working at about 40 to 50%, which is still kind of wild. I didn't think they could get there. That being said, when you have an ALS patient who is going to work every single day, completely locked in, using their implantable interface to engage on Zoom, to engage in meetings, to write briefings, that 97.5% is incredibly important. And so I think we'll just have to see how this kind of nets out over the next few years. I'm increasingly encouraged by what we're seeing coming out of these AI systems that are non-invasive, but for now, for the patients who need it most, it seems invasive is really the only way to get the high quality data, to get to the accuracy needed for them to restore function in the workplace. And that's really what we're most excited about, is getting them back into work and restoring their independence.
Thank you. Kate?
So nice to be here today. I'm a neuroscientist and engineer and the inventor of actually the medical therapy that I'm wearing here today. This is a treatment. It is regulated for the treatment of essential tremor and Parkinson's disease. And it works by actually measuring patients' movement and then individualizing stimulation pulses to treat that patient's tremor. I'll speak a little bit on this on the more medical versus consumer side of the spectrum. I think there's just huge potential for technologies like AI and its interface with the nervous system to treat patients. And certainly actually thinking yesterday even of Bill Clinton's wonderful comment around democracy not being just about treating the minority, the majority I should say, but about also treating the minority, about treating the disabled and treating the diseased. I think that this is one of the areas where many of us in the field are currently focused on, is how do we leverage these technologies to treat, as Jennifer mentioned, the many patients who are struggling with neurologic conditions. I'd also note that this is one of the areas where the regulatory frameworks are most robustly developed. So if you look even here at this forum on many of the concepts around democracy, we keep hearing, coming back to the fundamentals of ideas of transparency, of accountability, of responsibility. These are all built into the regulatory frameworks, in our case, both in the development of the therapy as well as in the distribution of therapy, protecting privacy, for example, of patient data through there. So this device is available. It's in the US with a physician's prescription. And I think that this is really a model that we can also look at expanding on some of the robust regulatory frameworks that have been developed in the medical space and expanding some of that out appropriately into the consumer space as well.
Thank you. As technology blurs the line between human and AI enhanced capacities, should enhanced individuals have new rights or responsibilities? How do we maintain fairness for those who choose to remain unenhanced? Jared, do you want to start?
Yeah, I mean, it's a great question. We are on the cusp of enormous mental augmentation. It's already being done. I'll just reference one study to give an example of what I'm talking about that will have both medical applications and general enhancement applications, which was a study 2 years ago at Boston University that was done on short-term memory in senior citizens, and with neurostimulation to the part of the skull from the outside in that's associated with short-term memory. The study demonstrated that the researchers were able to actually enhance the memory of senior citizens by 40% in their memorization of a list of 20 items. This is just the very beginning phases of enhanced memory coming from neurotechnologies. Obviously, this is going to be most important for people that have serious neurological disorders. When you think about Alzheimer's disease, for example. But you can also imagine a scenario where you're a university student and you want to do better in class, and one of these devices comes on the market. What's going to happen in terms of being a driver of major inequality if some people can afford the technology and other people can't? And how do you deal with that? So the Neurorights Foundation actually just did a seminar on mental augmentation. You can find it on our website, neurorightsfoundation.org, but a 4-hour seminar on mental augmentation and where is it coming. That's going to be much slower. The writing to the human brain, or the altering brain activity, is much more challenging than decoding. And so the decoding technology is much further along, and it will be slower mental augmentation. But we will be there, and we are at our foundation are beginning to think about what legal and regulatory frameworks we actually need. But a right of fair access is obviously going to be incredibly important. But practically, how does one implement that from a resource perspective is going to be a gigantically important question in years to come.
Jennifer, do you want to add to that?
Yeah, I'm happy to take that. I think, just to dovetail what you had just talked about is, when we think about implanted devices, right? We no longer see them. We're not wearing something. And I remember interviewing one of the first people that ever used a retinal implant. And now a retinal implant allows a person who is blind to be able to have a device that allows them to see, but they have to wear these glasses and an external processor. And you know what concerned her? Her concern was that how are the glasses, how does she look in public with these glasses on? Now mind you, this woman's blind, but she's concerned about how she looks and what type of wearable that she's wearing. So when we think about wearables versus implants, implants become much more intuitive. It's an implant it and forget it. I have an implanted device and you can't see it right now, but I use it on a daily basis. And I think as we start to look towards implanted devices, there's a lot of salient issues around that as well. And last year we launched the Implantable Brain-Computer Interface Collaborative Community. And this is a collaborative community that brings together industry, researchers, patient advocacy organizations, and also our regulators and our federal agencies to work together to help solve some of these salient issues that are around this type of technology, like who owns your data, like informed consent, around modularity and interoperability, and around clinical trial endpoints, and start to create some of these regulatory frameworks and some of these frameworks that where we need to help solve the problems together, not individually. And I think this collaborative effort is a way that we can move this technology forward so we don't end up in a situation where we are today with AI and social media, but we're ahead of the curve and we're all working together to make sure that we have some guidelines and some guardrails around the development of this technology.
Miguel?
Yeah. In similar case, we have the sample of Neil Harbison. He is like the first cyborg in the world because the UK government has said that he is from Barcelona too, but he was living in New York too, and he implanted an antenna in the brain because when he born, he can't see the colors. One robotic engineer speak with him and tell that if you put antenna in your brain, you can hear the colors because the onda is the same production. Now he is hearing the colors. Yeah, but nobody can put this legal because we don't have the laws for protect the he make like in the illegal way in New York 15 years ago, and it's working today, but no one think that it is important because maybe you don't have a lot of people that don't see the colors, and maybe it's not economical right.
Given how BCIs collect and process neural data, how do we safeguard autonomy and guard against manipulation or mind control? What role does informed consent frameworks and regulatory measures play in preserving mental sovereignty? Taryn, do you want to speak from the industry perspective?
Sure. I mean, we are still in the early stages of these kinds of conversations. User control is non-negotiable. In the 40-some patients that have been implanted, they are going into a lab. There is, these devices are not readily available for public use. There are scientists that are running them. And the systems really are not built for passive monitoring. So there has to be active and intentional use of the systems, intentional thought recording in order to actually interface with the devices. But I think it really becomes imperative to work closely with regulators and ethicists and the patients themselves in sort of determining how do we continue to build these systems in a manner that's safe and in a manner that enables and protects autonomy.
Kate, do you want to do that?
Yeah, just building exactly on those areas. I think that the established practices, first of all, around consent is tremendously important. Consent is also a different process when, for example, someone is using a device that is already on market versus when someone is participating in an exploratory research study. And I think that that's one of the areas where the field just needs to tread both appropriately and transparently in proving that there is a highly favorable risk-benefit determination prior to releasing new technology or new technology improvements into the market. And that's where, for example, companies like Cala, we go through a series of submissions to in the US, the Food and Drug Administration, as we desire to add additional functionality that comes along with all of the necessary communication to patients, as well as generally in large-size clinical studies that actually demonstrate the favorable risk-benefit determination prior to releasing new technological features into the world.
Jennifer?
Yeah, so I think when we just want to dovetail what Kate just said is about informed consent. Informed consent is incredibly important, but informed consent is wrought with legal language that the average person can rarely understand. And it's a very difficult document. Sometimes you'll be hand informed consent. There are papers and pages long. How can somebody actually agree to that? Do you actually read the terms of use before you say okay? You don't necessarily. And so as we move forward with informed consent, we need to come up with better ways of informed consent, easier ways for people to understand them. And also, when we think about informed consent, what is dynamic informed consent? Because as technology changes so rapidly, how do we have informed consent that can adapt as the technology adapts? And I think there's a lot of ways that we can do that, but we can't do that at the cost of technologies that are helping people today when we start to think about what are the potentials of the future. And I think one of the salient issues that doesn't get addressed in a lot of these forums where we get so excited about the technology is we don't address an elephant in the room, which is abandonment. What happens when a company goes out of business? What happens when technology becomes obsolete and then that technology that they either have implanted in them or that they're using externally is no longer available? We've been dealing with this for the last 2 decades. So think about this, in early 2000s, neuro control went out of business, leaving hundreds of quadriplegics paralyzed again. Only a few years after that, Northstar Neuroscience went out of business and had to explant technology out of people's brains who were stroke survivors. Even more recently, Second Sight went out of business that allowed people to be able to see. Luckily, that technology went to another company so that now they're able to service them. But there's organizations like Autonomic Technologies, like Neurovectra that went out of business. How do we build guardrails and how do we build our regulatory and our policy making around the abandonment issue so we don't keep facing these issues as they go forward and as technology develops and as it becomes much more pervasive within our societies.
I would agree. We have a lot of discussions about that. These are expensive technologies, that to maintain the technology is expensive. And if a company goes out of business and you don't have some sort of trust that has been previously set up to take care of these patients, it's a very frightening position.
Thank you. Unfortunately, we're able to touch on all the topics, but I do want to just do a rapid fire kind of lightning round where in a single sentence, describe your greatest hope or fear for a society shaped by BCIs in the future, and we'll just go straight down the line. Miguel?
Yeah, in accord with the other questions, I'm sorry, I think that we only need a clear regulation, transparency, and ethical laws. A new reality in front, and we only need a new regulation for this control and that you speak on.
Thank you, Miguel. Jerry?
Yeah, I mean, I would do more than a sentence, maybe 3 or 4. I mean, lawyers. I hope you forgive me. You know, I think, as was said earlier, obviously, this is science, not science fiction now. There are already 30 consumer neurotech products on the market today you can buy for purposes of wellness or gaming or kind of do-it-yourself, you know, EEG scanner. And our the Neuroscience Foundation published last year a study looking at the user agreements for these 30 companies and benchmarking them against a half dozen global privacy standards. And it's fair to say that they fell woefully short of what one might expect and hope for. You can't have informed consent, for example, when only half the companies even tell users that they're gathering neural data, let alone define it. And today we can only decode 1% of what's in a brain scan. So how do you have informed consent on a forward-looking basis when that number rises to 2 or 3%? Eventually, you know, my colleague at Columbia, Dr. Rafael Yuste, would say, you know, we're going to be able to decode our subconscious thoughts, right? But you can't give informed consent today for a technology that it doesn't yet exist. And so we need to rethink informed consent in a major way.
I would just say that watching patients achieve real-time breakthroughs, whether that's restoring movement, being able to operate a robotic arm, you know, being able to speak again in their own voice, they're just mind-blowing. And so, yes, I do believe that with brain-computer interfaces, we will see leaps forward in human evolution and the way that we interact with the world. And I think it's important to remember why we're all here now, which is for the people who are desperate to restore their function. And I usually prefer to have them answer these questions because it's really interesting what they have to say about both their capabilities being restored and the new senses that they're gaining. And I find that really interesting. And so for people like me, I think the focus should be on responsible development, but not resisting progress.
Yeah, I think it's having bioelectronic therapies for the many, many disorders that are known to be electrical in nature. It is just absolutely life-changing for patients when you restore people's control of motion, whether it's being able to, you know, eat, drink, write, walk. This is feasible with our technologies and with responsible development. So let's all keep working hard to help all those patients. Yeah.
Whether it's invasive or non-invasive hardware, the real challenge is the neuro data, the sovereignty of that neuro data. And understand that the solution for that is obviously personal agency. The person should own their agency of their data. I think that solves a lot of the issues here because you have to be aware of what is in control now. You or the institutions or the governments having your data.
So I'm incredibly excited about this field. I think we have tasted the potential of predictive and personalized treatments. I think we recognize that we have to put on social guardrails for autonomy, agency, and human rights. But I think we are now at the moment where we need to help build the infrastructure for responsible innovation. And I think that's where we are going today.
Thank you all for sharing your insights into this fascinating and sometimes daunting future of BCIs. It's clear we're at a crossroads where innovation and ethics must go hand in hand. I hope this conversation continues beyond today. Thank you, everyone.